Okay. So we're looking at a completed process of completing the square. I'm just going to give it a little title here. You've done all the correct steps. I'm going to recap them really quickly. So we had our standard form. You factored out -4 from the first two terms. You ended up with this bracket. You then took the new b value, put it into a little formula here where you divided it by 2 and then you squared it. And that's what you added and subtracted in the bracket. You then took the negative value to bring it outside the bracket. You had to multiply by the coefficient, so it became +4. And then I jumped all the way down here because your last step was to square root the first and last terms in the bracket. Those became the two terms. You bring the operand or the operation in front of the middle term, that negative, and then you just kind of simplified your last terms. But why or how did we go from here to here? The reason that we go through this whole first process here is you're creating what's called a, I'll try to fit it in here, perfect square trinomial. Sorry that I didn't quite fit the size there. And a perfect square trinomial has an equation that looks like this: a squared plus 2ab plus b squared. That process created a perfect square trinomial. That's what this middle term in the bracket is. Okay? So you can shortcut factor a perfect square trinomial by just jumping right to here, by taking the square root of the first term, square root of the last term, just like we said, x and 1, and bring the operation, and boom, you're done. But, you know, why? How do we know that this really works? So what we're going to do is I'm actually going to go through decomposition with you very quickly. It's a process we're familiar with, and we need to know it anyways for factoring. And what ends up happening is we're going to factor this, and we're going to end up with two brackets that are the same, right? And that's why we can represent it as one bracket just to the power of 2. Okay, so we're going to go through the decomposition of just this bracket here. So I'm kind of skipping out the other numbers. We're not focusing on them. We're just going to look at x squared minus 2x plus 1. Okay, we look for two terms that multiply 2, and because the a value is 1, a times c is 1, so two values that multiply to 1, and they're going to add to the b value, -2. So what two numbers do we have that multiply to 1 but add to -2? Can you think of any?
Wait, what do you mean? Wait, pardon me, can you repeat it?
Yeah, two numbers that multiply to 1, and then they also add to -2. And what's good about multiplying the 1 is there's
1 and 1.
Yeah, exactly.
Or -1 and -1.
Very good, very good. So -1 and -1 are our values. So when we do decomposition, what's happening here is we're taking that middle term, this -2x, and we're going to represent it as -1x, -1x plus 1, okay? We're then going to, and notice I'm not writing equals y or anything because technically this isn't the whole equation. Yeah. So we're just decomposing the middle here. I'm going to find a common factor out of the first two terms. So I can take x out. When I do that, I'll be left with x minus 1. And over here, we can take out -1 as a common factor. And we're left with x minus 1 again. We know through decomposition that that now becomes x minus 1. And then whatever was left over from the other bracket, x minus 1. Okay? And we know from all of this process that that can be just written as x minus 1 to the power of 2. So instead of going through the decomposition, which is all of this here, every single time we complete the square, we know that if I get the first part correct, this whole funky process, this algorithm, if I do that correctly, I've created a perfect square trinomial, which means I can just jump to this shortcut step. I don't have to do this decomposition every time, okay? And that's the reason we take those first couple steps, is to make this something that's easy to factor that ends up as two brackets that are the exact same.